Section 6.5 is on solving exponential equations. For your learning targets, you will be able to solve exponential equations with the same base, and you will be able to solve exponential equations with unlike bases. For our core concept, we have the property of equality for exponential equations. So basically what this is saying is that if you have exponents with the same base, you can set them equal and then solve for their exponents, like make an equation out of their exponents. Example 1 is solving exponential equations with the same base. So looking at our first problem, we have 4 to the x plus 3 power is equal to 4 to the 9th power. So we have 4 as our same base. So now we're going to make an equation out of the exponents. So we're going to use x plus 3, so the exponent of the first one, and we're going to set that equal to the exponent of the second one, which is 9. So then we're going to solve this equation for x. So I subtract my 3 from both sides. So these cancel, and we have x equals 9 minus 3 is 6. So 6 is our answer here. Our next one, we have 2 equals 2 to the 3x minus 2 power. So when there's not a power here, there's a 1. So there's really a 1 right there as the exponent. So we have 1 is equal to 3x minus 2. So now we want to solve for x. So we're going to start by adding the 2 over. So 1 plus 2 gives us 3. I bring down my 3x, and then the negative 2 and 2 cancel. So then now we're going to divide both sides by 3 to get the x by itself. So we have x equals 3 divided by 3 is 1. So our answer here is x equals 1. And then our last one, we have 8 to the 3x minus 4 power is equal to 8 to the 2x plus 1 power. So again, we're going to set the exponents equal. So I have 3x minus 4 is equal to 2x plus 1. So I'm going to start by subtracting the 2x from both sides. So remember, I like to get the x's all together on the left side first. So 3x minus 2x is 1x, or just x. I'm going to bring down the minus 4. My 2x's cancel, and then I bring down my 1. So now I'm going to add the 4 over on both sides. So we have x, these 4's cancel, equals 1 plus 4 gives us 5. So x equals 5 is our answer for this one. Example 2 is solving equations with unlike bases. So in example 2, we're going to have to either rewrite one or both of the bases. So looking at our first one, we have 6 to the x is equal to 1,296. So first we want to see if 1,296 is a power of 6, which it is. So I'm going to rewrite my 6 to the x, and then 6 to the 4th power is 1,296. And this is kind of just found by doing guess and check. So now that I have like bases, I can set my exponents equal to each other, and the x is already solved for. So here my answer is x equals 4. And my next one, I have 9 to the x power is equal to 3 to the x plus 2 power. Looking at our smaller number here, which is 3, we want to see if we can rewrite 9 as a power of 3. So I want to know, is 3 to a power going to give me 9? And that's yes. 3 to the 2nd power is 9. And then I'm going to copy down the rest of this. So now I have 3 squared in place of the 9. And here I have a power to a power. When we have a power to a power, we need to multiply. So this becomes 3 to the 2x power. And then I'm going to bring down my 3 to the x plus 2 power. So now I have like bases, so I can set the exponents equal. So I have 2x is equal to x plus 2. I'm going to subtract the x over. 2x minus x is 1x. These x's cancel, and I bring down my 2. So x equals 2 is my answer. Then for our last one, we have 4 to the 2x power is equal to 8 to the x minus 2 power. So we're starting with our smaller number 4, and we want to think if we can rewrite 8 as a power of 4, which we cannot. So 4 to the first power is 4, and then 4 squared is 16. So a base of 4 isn't going to work. So we actually have to rewrite both of these using a base of 2. So I'm going to rewrite this just with my base of 2, and then we're going to go back in and fill in the powers. So 2 to what power gives me 4? That's 2. 2 to what power gives me 8? That's 3. So now again, we have a power to a power. So we multiply. So this is going to become 2, and then 2 times 2x is 4x. So 2 to the 4x power is equal to 2. And then here we have a power to a power. Here we have to distribute this 3. So this is going to be to the 3x minus 6 power. So now we have like bases, so we can rewrite our equation of our exponents. And then I'm going to subtract 3x from both sides. So 4x minus 3x is x. The 3x's cancel, and we have negative 6. So x equals negative 6 is our answer here. Example 3 is solving now when one of our bases is a fraction. So when we look at this first one, to rewrite this, we need to get rid of the fraction. So we're going to use a negative exponent. So if I rewrite this as 6 to the negative 1 power, 6 to the negative 1 power is 1 over 6. So the first step is just to rewrite it using your negative exponent to get rid of the fraction. So now here I have a power to a power, so I'm going to rewrite this as 6 to the negative x power. So now this side has a base of 6. So now we want to see if we can rewrite 216 as a base of 6, which we can. So 6 to the third power is 216. So now that we have like bases, we can make our equation. So I have negative x is equal to 3. And then I need x to be positive. So I'm going to divide both sides by negative 1. And we get x is equal to negative 3 as our answer. The same thing in the second problem. We have 5 to the x plus 3 power is equal to 1 over 25. So first we want to rewrite this fraction using our negative exponent. So I'm going to copy down the 5 to the x plus 3 power. And this is going to become 25 to the negative 1 power. So now I have 5 and 25. So 5 is my smaller number. So I want to see if I can rewrite 25 as a power of 5, which I can. So 5 squared is 25. So I'm going to bring down the left side over here. So now again, I have a power to a power, so I need to multiply those. So I'm going to bring down my 5 to the x plus 3, and that's going to equal 5 to the negative 2 power. So now that I have like bases, I can set my exponents equal to each other. So we have x plus 3 equals negative 2, and then I'm going to subtract the 3 over. So we get x, these 3's cancel, equals negative 5. So x equals negative 5 is our answer for this problem.